Hello everyone. Today I'm going to talk about using machine learning to predict student academic success based on socioeconomic factors. Now, this is a joint work between the Lviv University of Trade and Economics, which I represent, and the Lviv Polytechnic National University, and I'm excited to show the findings which we have developed. Now, the core question we're asking is, can we identify students at risk of academic failure before it even happens? Now, predictive modeling uses machine learning algorithms to forecast outcomes from input variables. If we can predict which students are likely to struggle, we can intervene early with targeted support instead of waiting until they have already failed. So it's about being proactive instead of reactive in education. Why focus on socioeconomic factors? Because student outcomes aren't determined solely by intelligence or effort, as they are profoundly influenced by external circumstances which students often can't control. These are things like parental education, occupation, household income, family relationships, available study time, and lifestyle factors. The idea is that a brilliant student in a chaotic environment will struggle a lot more than an average student, but one with strong support systems, and we want to ask if these indicators could build meaningful predictions on a student's grade. So to discover this, we've used the UCI student performance dataset with 1,000 students from two Portuguese schools and 33 socioeconomic features. We combined math and Portuguese courses and converted the final grades of the students into binary pass and fail outcomes because that's the most actionable questions for educators. Will a student fail or not? Critically, we focused on non-academic indicators, so we didn't focus on prior test scores, because if you need previous grades to predict future grades, that's not particularly useful. So for data preparation, we've removed intermediate grades, as mentioned, to avoid leakage or strong correlation, encoded categorical features, normalized numeric features, and used a stratified 80 to 20 train test split. As the data set showed, 65% students passing and 35% failing, which is a slight imbalance, but expected for a typical school, and in fact might indicate a more underfunded one. So we've tested four gradient boosting models. XGBoost, known for being fast and accurate, Light GBM, handling efficiently large categorical datasets, CatBoost with native categorical variable support, and then there's Expandable Boosting Machine, or EBM, which is designed specifically for interpretability while maintaining high accuracy. Now, in education, this matters a lot because we need to be able to explain automated decisions. We evaluated everything using accuracy, precision, recall, F1 score, and area under curve. So let's move on to our results. All four models performed well with accuracy around 78 to 79%, which validates our hypothesis that socioeconomic factors have real predictive power. What genuinely surprised us is IBM didn't just offer the best interpretability, but also overall the best performance across most metrics. So it had a recall of 93.85%, which means out of every 100 students who actually failed, we will correctly identify 94 of them. So this is absolutely crucial for an early warning system because we just have some alarms that miss students who need support. Now looking at the confusion matrices and the ROC curves, all models significantly outperform random guessing, and the confusion matrices show that all models are particularly good at identifying true positives. And for educational intervention purposes, we generally want to prioritize recall from this matrix. So what actually matters? Past failures were the strongest predictor, which is maybe possible, maybe obvious, but next predictors are whether students had paid educational support, which schools they attended, the mother's education level, going out with friends, school support availability, intentions for higher education, a guardian type, and various family factors. Now, what's really striking is how much of this is generally about environment and circumstances instead of just the student's inherent capability. Now, the limitations is that this dataset comes from two Portuguese schools, which is pretty narrow, and the binary classification definitely oversimplifies reality a bit. Looking ahead, we're interested in multinational datasets, adapting this approach for Ukrainian schools, and developing practical dashboards which educators can actually use. Now, to wrap things up, machine learning can efficiently identify socioeconomic risk factors with about 78-79% accuracy. Experimental models give us both accuracy and interpretability, which actually outperforms traditional classifiers. And these systems can indeed guide early interventions to students which need them most. And of course, transparency is key to responsible educational AI, which is why experimental models are also a priority choice. Thank you very much.